At ProDevs, we specialize in connecting businesses with top African tech talent. Be you a startup or a corporate company, whatever your hiring needs are, ProDevs is the place for you.
Outsourcing with ProDevs means you get access to a global pool of highly vetted tech talent. From developers to designers to product people to data analysts, we ensure that the right and the best talents are working on your team and for you.
Looking for permanent hires? Our recruitment team is designed to match you with the top talents quickly and efficiently. We take care of the heavy lifting, from vetting candidates to getting the right cultural fit, so you get the best, faster and quicker.
Outsource the right tech talents, recruit the best fits.
Find your next tech hire with ProDevs.
We make tech recruitment simple, fast and efficient.
All right, good evening, everyone. You're welcome to today's webinar. My name is Daniela, and I'm super excited to have you guys here with us today. So today's session is titled How Top Developers Use AI to Ship Faster Without Sacrificing Code Quality. It sounds like a very exciting topic to me. We know how AI has become a major part of how many developers work today, how generally we work, and we know it's been helping teams move faster. It's improved productivity, but at the same time, there are still important conversations that we still need to have. There are still people that have been skeptical when it comes to AI, and that's why we're here today to explore how developers can take advantage of AI while still maintaining high engineering standards and building quality software. So joining us today, we have two amazing speakers. We have Victor Rex Nwachukwu, a senior full stack engineer at Vevana, who will be sharing his insights on AI-assisted development, system design, and making better technical decisions in an AI-driven world. And we also have our very own Ebenezer Boyimbode, senior software engineer, team lead at ProDevs, who will be sharing practical workflows, guardrails, and real-world strategies for using AI effectively in day-to-day software development. So Victor and Ebenezer, we're super excited to have you guys here with us today. Thank you so much for taking time to share your knowledge and experience with us today. So without taking much of your time, I'd like to welcome Victor to the stage.
All right, thank you so much. It's a pleasure to be here. Please confirm if you can hear me very well.
Yes, Victor, we can hear you.
All right. All right, so just a little 1 minute intro about myself. So yeah, as she said, I'm a senior full stack engineer. I have over 8 years professionally coding in the industry. So I've been there, before even the boom of tech in Nigeria, and then, through the phase of, that initial boom, and now we're now in the AI phase as well. So, yeah, I think I'll go ahead and show you guys what I have for you today. So today I want to talk about how we top developers use AI to ship faster without having to sacrifice code quality. And I want to approach this from a practical perspective. So I'm going to be making use of, real world case scenarios where you've actually encountered or you can relate to as a developer. And I believe this is the best way to actually, get you to understand how to improve the quality of your code as you use AI. So first off, we already know that with AI, things have become really cheap. That's development cost has become really cheap. It's now easy to move from the idea stage down to the product stage without wasting so much time or having to go through a lot of friction. But however, one thing that has plagued the industry, especially with this boom in AI, is quality. These AIs are not mature enough to make decisions for you, and you still bear the responsibility and pay the cost of any bad decision you make in your code. And a lot of people talk about prompt engineering. Some people even go ahead to even take tutorials on prompt engineering. They tell you, okay, you need to tweak things this way. You need to use this particular phrase or text. It's going to make your AI, give you better output. Now, prompt engineering does not really replace systems thinking, engineering thinking. It does not replace that. And that is the most important aspect of software engineering that boosts quality. So no matter how fancy or superficial your prompts look, if you are not making proper engineering decisions, if you're not following the critical aspect of software development, you are basically going to miss out on quality. Now, let's look at an example of some prompts people use. So, for example, now people want to, a developer might want to build an e-commerce platform, and then they might be like, build an e-commerce platform using Paystack. That's the prompt they give the AI. That is, even so, sometimes they might go to the point of saying, okay, use Paystack, create a discount feature, create carts, create inventory, order trails. Sure, that you're actually listing out features, but you are actually how will I put it now? You are corrupting the prompt or the thinking flow you're supposed to follow to be able to increase the quality of your output. Because what happens when you follow that pattern is that you end up with things like tightly coupled systems. For example, mentioning the word Paystack there already makes your AI think that Paystack is the most critical aspect of your product. And before you know it, you end up with a very tight coupled system that only works across Paystack. You cannot consider, adding extra payment providers like Stripe or Flutterwave. The best approach would be something like build a payment abstraction layer supporting multiple providers. So with that, you see that it has more clarity as to what feature it needs to build. And you can see that we are not trying to build the entire e-commerce platform in one prompt. No, we are trying to build layer by layer, section by section, feature by feature. Now, when working with AI, there are three things you want to ensure that you get correctly, or there are three main goals you want to make sure that you have before you hand implementation over to the AI, before you click build or tell the AI to start the implementation process. One of them is gaining full context. The other one is ensuring that you understand the edge cases, of the implementation you're trying to do. You're trying to do an implementation of a payment service. You want to ensure that you understand the edge cases of this payments, of what it takes to build a payment service. You want to understand the trade-offs. What are you losing out from based on the implementation flow you decided to go with? Based on your architecture, what are you actually losing out from? Now, when it comes to full context clarity, it's very important to avoid tunnel vision. Tunnel vision is basically where you only see things in one direction. For example, the previous thing we talked about, building an e-commerce platform using Paystack, that's tunnel vision. That is making it seem like the e-commerce platform is all about Paystack. And we know that there are a lot of things that goes on in building an e-commerce platform. So, for example, let's look at the payments layer now. If you want to ensure that you have good quality, you want your AI agents to gain full context as to, okay, I intend to use Paystack as my payments provider or as my primary payments provider, but there is a tendency I can also adapt other payments providers like Stripe or Flutterwave or any other payments provider at all, into my system. So it begins to see things as, okay, there is no point in tight coupling your implementation to Paystack. You avoid that issue entirely. Now, when it comes to things like edge cases, we all know that, okay, there is a happy part in a software or in a feature. When building a feature, there's a happy part whereby you know that, okay, let's say for something like authentication, like you just need to input your email, password, and then you log in. That's the happy part. It's supposed to work. You understand? But what about the edge cases? Still going back to the Paystack example, things like fake or malicious webhook calls, things like duplicates, webhook events being fired, things like invalid commands, being received from the client side. So you want to ensure that you guard against these things. You want to ensure that when you're actually doing your development process with AI, there are actually guardrails against these edge cases. You understand? Don't just see the happy part and tell it, okay, implement the happy part alone. You need to ensure that your AI is actually guarding against these edge cases. Then trade-offs. Now, trade-offs is where we now talk about what you're losing out based on your architecture. For example, if you're building a banking application, you know that you heavily need to prioritize security. And the process of prioritizing security actually reduces convenience. So basically, the application becomes a little bit inconveniencing for the user. For example, their tokens might expire way more frequent than a normal application. You understand? They might need two-factor authentications to log in and all those stuff. So this is necessary. You get the security is necessary, but you need to be aware that you're losing out on confidence. You might be losing out on performance when you want more flexibility. It could be, you're looking at better experience with animations and all that, and because of that, it's costing you on performance. So you need to be able to do your cost to benefit calculation, know what is worth it, and know when it is not what's the trade-off. That's what you're trying to implement, is not what's the trade-off. So now I'm going to talk about my development workflow, basically how I go end-to-end from an idea stage down to being able to ship the feature or ship the product using AI. And the first part is research and discussion. So basically, this is the point where I have an interaction with the AI agents. You understand? Research, discussion, thinking, formulating, architecture. This is where all those goes on. Now, the point where I consider this phase as done is once I have the three things I talked about, which is full context. My AI now has full context of what I'm trying to build. I have covered the edge cases. I have made sure that, okay, the plan I'm trying to build out, or the plan I have to build this feature out, has covered the edge cases of where things could go wrong. And then I know the trade-offs of the decisions I'm making, even the micro decisions. You want to ensure that you actually know the trade-offs of those little decisions. Now, diagrams, very, very important, especially for backend developers. This is very, very, very important. You should always ask for diagrammatic representation of your flow process. Know how data is flowing in your system. You understand? Be it logic, be it entity relationship between tables in your DB, be it your endpoint sketches, or basically your system architecture. It could be how different services or different services are basically interacting with each other, including the third-party services as well. So you want to have these diagrams. It helps. There is this library you can actually use to make diagrams. It's called Mermaid. So you can actually ask your AI to write or create Mermaid diagrams of, to represent the flow process of what you are trying to make. It helps you visualization. It helps you to understand, what is actually, how the implementation process is going to go. Then, yes, I already talked about edge cases. So you need to ensure that, yes, you've covered the edge cases, but ensure that you have tests as well to actually cover those edge cases, the happy parts and the edge cases. The edge cases being the potential points of failure. What happens when somebody gets debited twice? Does their money get refunded to them? What happens when a webhook is called multiple times? Is there idempotency rules that helps to prevent against duplicate runs and things like that? Now you definitely you have to do your unit and integration testing, your end-to-end testing, but you can make use of libraries like Postman and Maestro to do to help assist with your testing process. So basically, there are scripts you can write for Postman, and yes, also for Maestro. Maestro makes use of YAML scripts. Postman makes use of JavaScript. So you can write, or you can tell your AI, actually, it's easier that way, to write test scripts to test against the happy parts and then the edge cases of the implementation process. So once the building phase is done, you can easily run those tests to ensure that things work end to end. Now, the building phase, this is where the AI gets to actually handle the building process, writing the code, and all those stuff. So at this phase, you must have, before you get to this phase, you must have already confirmed those three things I talked about, which is full context, edge case handling, and trade-offs. You must have gotten these three things ready before you actually move into your building phase. Now, once the building phase is done, the next phase is review. Yes, the moment your AI is done building out a feature, always read the summary. That is the first review process you should do. Read the summary that explains, okay, this is what this AI did. Some of the products like Claude and Cursor, they try to give you a very detailed summary as to what those agents touched during the implementation process. So read the summary first, then go into the file review process. You should do a human review, which is the manual review process, whereby you review the different files by yourself, and then you can also have an automated review process. Now, when it comes to review, there's one thing that is very important to say. Right now, code review is an underrated skill, and it is very important to the era we are in, regardless of what your level is in software engineering, both junior developers, mid-level, senior level, everybody is supposed to be good at reviewing code. And one thing people try to do when they review code is to try and look at that code from multiple lenses at the same time. So you can see someone trying to review a code and he's checking for conventions, the team's convention, how they use their variable names, their folder structure, routing and all that. He's also trying to check for engineering standards like solid principle, KISS, and the rest of them. He's also trying to check for vulnerabilities. He's also trying to check for edge cases. We humans don't have that level of mental context at once. Even an AI, don't even use an AI to do that. You look at your code one lens at a time. So first, you do your review for your edge cases. You do your review for your system performance. You do your review for security vulnerabilities. Where are the places where we might be messing up security-wise? You do your review for engineering standards separately. Now, it's easier to do this with AIs, but it is, even if you want to do it with an AI, that you want to use an AI agent to review the code, it's often best that you ensure that the AI agent understands the lens it needs to look at the code from. Don't just tell it, review my code and ensure that it works fine. No, that's bad. You can say, review my code to ensure that the implementation process meets the general engineering standards that we have across the industry, solid principle and the rest of them. Or you can say, review my code to ensure that the edge cases that we agreed on, that we needed to guard against, are actually implemented properly, that the guards are implemented properly. Or review my code to ensure that we don't have performance issues in the future. Or review my code against security vulnerabilities. So make sure the AI actually understands how you want to approach the review process. Now, the next thing you need to tell yourself is when you're about to ship a code, you need to understand that, or you need to ask yourself one very important question. The code you're about to ship, or the PR you're about to merge, or the feature you're about to release, based on the implementation, based on the amount of work, based on the amount of context, based on the amount of testing you have done. If my teammate was, if this was to be my teammate, would I approve this PRO, or would I ship this code if I were to be the one to write this code with this level of context? Because that's another thing. You don't want to be in a position where you have no idea how a particular flow, functions. You just left autonomy in the hands of AI. No, you want to ensure that you have full context of it as a person, and your AI also has full context as well. So once you can answer the question and say, okay, I have full context, I believe that concrete testing has been done, I believe that proper edge case coverage was done, I believe that the code is secure, you understand, you've basically done the work. If you have confidence in it, you can ship it. But if you feel like there is something missing, please improve the code. Find out what is missing and improve it. Now, one last thing I would just love to say is that AI is just a tool. It is not the defining factor of quality. Your quality of delivery still depends on your thinking strategy. That's how good are you at thinking. If you're a bad engineer, AI will basically amplify, your bad habits. And if you're good as an engineer, AI can also amplify your good habits that helps you produce better code. So just know that AI is just a tool. The real um, the real source of quality comes from your thinking process. So yes, that is all I have to say. If you have any questions or if we are going to move forward, then that's fine.
All right, Mr. Victor, thank you so much for that. I personally learned a lot, so I don't know if anyone has any questions before we proceed. Personally, I have a question. So it's the part where you mentioned gaining context, edge cases, and trade-offs. Um, do which one do you think developers mostly or frequently neglect when working with AI?
Okay, so I would say edge cases are usually the most neglected because, like I said, we often have this temptation of falling into tunnel vision whereby we can see things only in one path. And usually, especially when developers are in a hurry, they could end up just looking at the happy part. Okay, we need to implement authentication. It's just email and password, and that is the end. So people often neglect edge cases. So yeah, that's what I would say. People need to pay attention more to.
Okay, thank you. And one more thing before we proceed. How do we decide which edge case must be addressed immediately and which one can wait?
Sorry, I didn't get that.
I said, how do we decide which edge case can must be addressed immediately and then which edge case can wait?
Okay, so yeah, that is actually a question of priority, and I would love to split it into two. So there is technical depth, and there are let's just call it vulnerabilities, things that are potential points of failures. Yeah, that's a better term. So there are technical depths and there are potential points of failures. You do not keep potential points of failures for later. There's this famous saying that if anything can go wrong, it will go wrong. So it's often better that when you know that something is a potential point of failure, for example, people can impute invalid emails during their sign-up process or during their login process, and then they complain they are not receiving OTP codes. It's a potential point of failure. You need to ensure that you are validating your email. It's not something you try to keep for later. But then a technical debt could be something like, okay, the folder structure or the naming pattern in the code base doesn't really seem to rhyme with the team's objective. Now, that can be kept for later. So yeah, you should just be able to define what is a potential point of failure and attend to it as fast as possible.
All right, thank you so much for answering those questions. I don't know if any other person has any question before we move to the next speaker. Okay, so we have a question here from um, Ola. Sorry, I can't pronounce the full name, but yeah, it says, how can I set up AI agents without AI agents working hand in hand? That is, if one agent generates code, another agent reviews the code in the background. What tools can handle this? Is it Claude? Is it Cursor? etc.
Okay,
So I think the question is,
so I would say Cursor is the best at doing this so far I've seen. Codex and Claude can actually do this, but it's not a simultaneous process whereby as the code is being written, you're actually reviewing it simultaneously. No, it happens one after another. So implementation first, testing, then reviews as well. So Cursor has its own review section just directly under the you know commits tree, basically where you begin to see your commit messages and your commit history. Directly above it rather. So you can give specific prompts and say, hey, watch out for this, or look, review the code from this perspective. And then you just click on review and it does the review process for you. Or if you're using something like Claude or using something like Codex, you might have to spin up an agent to scan, based on it's often good to do it feature by feature, not the entire code base at once. So you don't burn a lot of tokens. But yeah, that's how you can approach it.
okay, thank you so much. Mr. Oladayo, I hope that answers your question. So we'll be moving on now to the next speaker. Please, if you have any more questions, feel free to drop them in the comments and then we'll take all the questions you have once we're done with the next speaker. So we'd like to invite Ebenezer to the stage to make his presentation. Thank you.
Okay, thank you so much, Princess. Hi everyone. You're all having a great day today. Go ahead and share my screen. Not this. 1 second. So I'll try to. Please confirm when you can see my screen.
Yes, we can see your screen. Oh, no, we can't see your screen now. Okay, we can see your screen now.
Okay. Hi everyone. I hope you're having a great day today. Glad we are meeting up today. Today we'll be talking about how does top developers use AI to ship faster without satisfying code quality. In today's current world now, it's so unfortunate that the quality of codes that is going out right now, it's so alarming in terms of not just implementing features now, but the code, the kind of codes going out, are they maintainable? It is something that if something is happening 2 a.m., you can fix yourself without having to prompt another agentic AI to actually fix for yourself. These are some of the questions that would actually be answering up today. So what does AI does? AI makes us to write code faster. So why do many teams actually ship slower? Even with the advent of AI, with AI coming on board, that we are expecting that AI should actually be able to help us to write code faster. The reality is some teams and a lot of teams are still shipping slower. Why? It's because AI writes the code, but without proper guardrails of what the AI should do or the process of what they're actually expecting. And at the end of the day, they push it to production. A lot of bugs start happening right there. They pull back again to local and still have to prompt AI again to fix the bug. All because there was no proper thinking process. There was no proper guardrails to guide the AI thinking flow. And that is why it's happening. Recent statistics has actually showed that 84% of developers are already using AI or plan to even adopt them this year. The reality is some of the OGs, senior engineers, are still very skeptical. A few of them, which is okay. Developers that were so used to Stack Overflow in the early years, in the early days of Stack Overflow, they did find the idea of AI abscond. But recently, statistics are saying that up to 84% of engineers are actually using AI for their day-to-day activities. So, which is one of the reasons why this conversation is very important. And 55% faster task completion when developer pair with an AI coding assistant. People tend to achieve faster. You get to go from ideation to production and testing your market fit of your product faster. And at the same time, too, there has been a decrease in the change stability for every 25% increase in our AI adoption. That is where the problem is. When there's a 25% increase in AI adoption, there's always a decrease in the stability if care is not taken of whatever product or code that was written with that AI. So speed without discipline is just faster technical debt. That means if at the end of the day, AI is giving us the speed, we are eating the market faster, we are achieving things pretty much faster than how we used to do. But unfortunately, technical debt is coming in. There are bugs that we ourselves don't even understand what is going on under the hood, and only AI that wrote the code can only also at the same time fix the bug. Then that's the problem, right? What is exactly the speed trap that we're talking about here? These days, more code are actually being copied and pasted, and there's less number of code that is being refactored. In fact, recently there was a time I was actually trying to test something with AI. I have a project that I'll say AI to just go ahead and refactor a couple of things for me. It ends up creating more problem. So it becomes a conversation of, are we directing towards the fast pace that the technology space is actually driving us to now? Or is it a time to also have conversation about the quality of what we are doing and not just only the speed? From research and researchers' analytics that have been going out so far, they actually make it so obvious that billions line of code are actually being written by AI on a daily basis. But unfortunately, the quality of it decreases over time. Thanks to some of the recent models that have been released by Claude, like the latest one, the Claude 5 Fab super model, by the end of the day, are these models really fast enough and sharp enough, like we human? Like I said, we are moving to a point where it will not be a function of, are you a software engineer anymore? It will be a function of share your experience about system architecture. It will be a function of how you actually catch edge cases. It will be a function of sharing your thinking process towards solving a problem or a feature or a bug, and not really about can you write the code and get it fixed. So I mean, you can actually get it fixed anywhere, but can the code be clean and simple enough in a way that you understand what your whatever tools you use have actually done for you? So what's the mindset? The mindset that I want you to take home today is to understand that AI is your fastest junior engineer you can ever hire. It's so unfortunate that it's even happening right now. The technology's landscape is shaping drastically. To those engineers out there, you can actually easily tell me when was the last time you really see a role that, hey, we are hiring junior front-end engineer, or we are hiring junior back-end engineer, or we are hiring junior full-stack engineer. Because these days, most engineers see AI as a junior engineer if you actually want to use it rightly. You need to start seeing AI as a junior engineer. And just like every other junior engineer, whenever any junior engineer you have in your team write codes and create a pull request, you as a senior person on the team, no matter how busy you are, you need to take your time to review that PR because you can't blindly trust it that it's going to do it. The same approach should be what should actually apply to when it comes to you using AI. See AI as a junior person, AI as a junior engineer, it doesn't know it. It just understands it, but doesn't know the core in depth of the kind of knowledge that you as a senior person have. So in that case, the first thing is AI will be very good for you for boilerplating and scaffolding your group codes. Starting the project, it will be good for you for AI. But what is left for you is that you are responsible for the architecture and the system design decision. Never leave that part of your project to AI. The architecture, the system design decisions, the speed in terms of the scalability of that project should not be something left alone for AI. You should be actively involved and participating in it. AI will be very good to translate clear specifications into first drafts. I mean, take up your entire PLD, throw it to AI. It's going to give you a clear specs and the first draft of what you should do. But when it comes to your naming conventions, your domain models, and your API contracts, you should never leave this to AI. You should be involved in it. Be the one to actually understand the API contract of what you are doing, right? AI will be very good with generating test cases and casting some edge case ideas that you might actually never think of as an engineer. But you as an engineer should never leave the security, the privacy, and the performance trade-off of your application to AI. It's so unfortunate that in recent time, more system has been hacked from 2025 up to date. There was a time I think that was in April or March, where Axios himself, a tool or a package used by millions of developers on a daily basis, was actually intercepted and a version of it was hacked. Imagine that you also upgraded your Axios package at that time when that happens, and blindly you push that package to your server. Then a crypto mining script will start running on the server, and before you know it, your server mics out. You cannot do anything on your server until probably you destroy the server or create a new one. Because those scripts sometimes always get access to some root case in your server that you might not even be able to entirely wipe them out. These are some of the issues with the AI advent now. So while generating tests, the security, performance, and privacy of your code, of your project, should never be left entirely to AI. I have a conversation with one of my colleagues earlier, and he was jokingly saying that in the next 3, 4 to 5 years, that cyber security expert that really knows what he's doing might actually be cashing out big. Because it's so unfortunate, which is true, because it's so unfortunate that a lot of systems are being built with AI, and we don't even know you don't even know what exactly is going on under that wood. A lot of security exposure is happening on your system, and before you know it, you can get hacked within 2 seconds, right? Then AI is very good for explaining unfamiliar code. This is something I myself do a lot. If you have a new project that you don't even know what's going on for now, you can run it to AI to actually go ahead to explain whatever it is that is happening on the code so far. What are the technical details that currently exist on the code? It's going to give you a good judgment. But AI should, you yourself and an engineer should know what not to build. Because if you tell AI that what feature can I have, you can trust me, AI will always have a new feature to tell you to add to that project. But you should be able to know what is the business decision. What am I trying to achieve? Where is the limit? Where can I push harder with this product? That is less for you as a person. And lastly, AI can help with the tedious refactoring, migrations, and documentation. But the final accountability of every match lies with you. Before you push that refactor to production, have you review what was refactored? Because I realized that recently, so far, sometimes 80% of the time that I've tried AI to do refactoring projects, it always ends up leaving some bugs for you to actually, you might not be able to even catch this kind of bugs until when you push it to production and your customers start complaining, oh, I can't do this. Oh, it was working yesterday, no longer working. Then you understand that your refactoring has caused some issues in the code base, right? So the final accountability and every match line is left for you to review. So what exactly is the big picture of an AI-driven system that is just not only AI-driven, but at the same time too, it is functional enough to be able to catch every grace, right? The first one is plan. Whatever feature I need to implement, whatever project I need to do, don't tell AI to go ahead and build, maybe you want to build something like Paystar. It's so insane for you to tell AI that, hey, I want to build Paystar to be able to accept multiple payments, and you're expecting him to actually build the entire architecture in just one prompt. It doesn't work that way. There should be a planning phase where you tell him that this is what you want to do. You want to build a payment system like Paystack. The feature is going to have to be able to receive payment. Businesses should be able to onboard, list it, like have a conversation with him one-on-one, like you're having a conversation with a junior person or with a senior person. This is what we want to build. Plan it first. After planning, the next thing is your design architecture. This is one thing that a lot of people miss out when it comes to making use of AI. AI is not omni-knowest. It works best based on the prompt that you give him. Let me give a good work scenario of what I always do. Let's say, for example, I have a new backend system for me to build, and it has to do with a system that will be able to process payments internationally, and maybe something similar to Paystar. You tell him, build something like this. Then the next is using, what stack are you using? Okay, I want to use Next.js as my core backend system. I want to use Postgres as my DB. I want it to be an event-driven system. If you are planning to go to microservice in the future, because you are trying to test market, and tell him, we are planning to go to microservice in future. So make sure that this is a modular-based system architecture, so that everything will be in module. Tomorrow, if you need to break it down to microservices, it's easier for you to move those modules to where they should be. That way, nothing is overly coupling tied together that might actually be a problem by the time you want to start scaling. If these conversations, if the design principles are not taken care of properly at the point of you actually having to design the system, it's a technical debt that the AI himself are not even able to solve in future if you are not careful, or create more bugs as it's trying to solve the existing one. Then after you are giving him the design system and the architecture, tell him to code. Then it generates the code. Go ahead and write 1 billion files, whatever it is that you want to write for you. And it's your come in again and review I have written the code. Go through every file. That is why I always advise that whenever I prompt AI and it went ahead, especially if it's not that the project is a new project that you're trying to scaffold, but for the fact it's an existing project, you prompt AI and it went ahead and start editing 15, 20 files at once. No, that prompt is not an effective prompt. That is just one way for you to know. If it's not a new project, and it's not as if you are building a new feature, but you're trying to fix a single bug, and you just prompt it and went and start editing 15, 20, 30 files in your code, it's time for you to actually go back and review it. It's either you've not prompted it correctly or the AI itself does not even understand what you're trying to fix. Right? Once the number of files is going bigger, for me, it's always a point for me to say, no, probably I've not prompted this thing correctly, or it's for me to go back, read through what it has changed. And most of the time, whenever I just say, okay, let me read through what it has changed, you realize that it has left a lot of technical debt or created problems for you in some of the features that is existing and working correctly. That is where you know. So you have to review it. Then after you've self-review it, then you now if you want to make any adjustment, that you need, then you throw it back to AI to go and write the test. You see, AI does the design, the planning. You come in with the designing and architectural system. You throw it back for AI to code. You come in at the point of review to see what he has done. You throw it back to AI to test. Because at the point of review, it's going to help you to maintain it. If you don't review it, you can't maintain what you don't review. You can't maintain a code, you don't know what is going on under root, right? Then you come in, AI comes in to run the test and the edge cases for you, which works fine. Then it's now left for you to keep maintaining. So in that way, if tomorrow something breaks and you need to fix it, even when the AI is trying to fix nonsense, you understand what is going on, so you can actually maintain it yourself. It's so unfortunate that these days, developers write a lot of code that they don't even know what is going on under root, and they themselves cannot maintain it. Then it becomes, something is breaking, we prompt AI to go and fix it again. AI fix problem A, create problem B and C. You go back and fix problems B, create problem C, D, E, like that. The stability of a lot of platforms these days has been dwindling and decreasing, all because of everything is relied solely on AI. Okay, so what's the principle? What are the principles? The first principle is spec first. Give the specification first. Then the second is you code. Never let AI to code without giving him the specification. You can't tell AI to say write a function to validate email. That is not a good prompt. Prompt engineering always requires context, constraint. If you want to, especially for engineers, if you want to prompt your AI properly, you should give him a context about what he's trying to do, then give him the constraints. Because you can tell AI to go and write a function that validates email. AI can go ahead and pull up a whole email validation package to your code base just because he wants to validate email for you. Right? And if you want to use package, you can say, okay, using this package, that means you are giving him constraints of what you use, so that it will not go ahead and start hallucinating. Then give him the acceptance criteria. For example, look at the left hand side. I said, write a function to validate email. That is not a good prompt. That is what most engineers do. But you should tell him that, give him more context. In the sign up, using TypeScript, write a function that actually validates an email. If you want to validate it on the client side, before using the DP, if you are using it on the server side, before actually saving it, or before coming, give him more context, right? Give him constraints. Is there any package you want to use or you have existing before? There was a code base I was reviewing this and I realized that the engineer has 3 libraries. I forgot the name of those libraries now. They are perfectly doing the same thing. 3 different libraries in the package.json, but the entire 3 libraries are doing the same thing. Why has this happened? So because different sessions with AI and how to put different libraries together into the code base. Then at the end of the day, you just realize that your code base is just large unnecessarily, and it becomes a problem for you to start managing or maintaining 3 different libraries, right? Give him that constraint and give him the acceptance controller. Oh, the email should have a heart. Oh, the email should not be a disposable email. Give him those constraints so that he'll be able to know what to do. And let's leave it for him to go ahead and write it back. So the first one is give him the full specification first and the code second. The prompt is the design doc. The prompt is the design code. Then what second thing is the principle 2 is the toolkit. The anatomy of a product grade prompt is that the first is the context, like I said earlier. Give it a full context. What are you trying to do? What do you want to do? So I want to build a front end with Next.js. The Next.js, I want to use Axios for my API calls. I want to use stack query for state management. I want to use movement for timing. I want to use this and that. Give him a full context that easily the AI could actually understand, right? The next thing is the task. Don't let AI run more than one task at a time for best efficiency. If your AI is running 15, 2, 3, 5 tasks at the same time, hallucination might come to a place and might not really be effective. If it is onboarding, starting with the onboarding flow, create an endpoint for login, log out, sign up, and forget password. Users should be able to log in to sign up with email, first name, last name. Give it just a task at a time. That way, it reduces the hallucination aspect of it. The second is the constraints. Tell him libraries to use and library nodes to use. Before the latest versions of Claude Code, in the early versions of Claude Code, like Claude 3 and below, most of those models were actually using old libraries that might not be compatible with the current framework you are using. Then it becomes a problem. Then you start using npm install --pl legacy because you don't even understand what the AI has done underwood for you. Or you start using npm install --force because you just want to force everything to production, which is not scalable, right? That is the constraint. Tell him the packages to use if you have any package in mind or you have your engineering process in mind. Tell it what to use and what not to use. Then the next is the acceptance. Tell it what is acceptable and what is not acceptable, right? Oh, the user should be able to have 5 requests per IP address to the login endpoint at a time. If user hits your endpoint up, maybe due to brutal force attack for 6 seconds, for more than 5 times in 5 seconds or in a second, then block the user IP for 10 minutes or 30 minutes. You know, those are the acceptance criteria. Tell it to him specifically, right? And the last one is the plan gate. Ask AI for an approach summary before any code. Let me tell him, but I realize that once I tell him that don't write code yet, give me a detailed plan, work plan of what you're going to do. From there, we have a conversation. Sometimes I change the plan, but I say, no, this plan is going to lead to more code or will be a problem. I change the plan and I say, using this process, using this method, approach it this way. That way, by the time it's coming back with the code, it's coming with a clean and well-structured that you yourself will be able to read and understand. Right. The third one is the small differences. Type loops. Never overturn your ability to review. Like I said earlier, prompt it. Once you prompt it, it generates. Read every line. Test it and commit. Like I said, test it and commit. AI doesn't catch from edge cases unless you actually explicitly catch it yourself. It might not be able to catch some edge cases unless you actually explicitly catch it yourself. And there are always 3 rules that I follow. The first one is the 100-line rules. If your generated differences is too big to review properly, that means the prompt was too big. Split the task, not your attention. Split the task. If like I said, if you are seeing that 1,000 differences are happening in your code, it means that prompt was too big for it. Break it down into chunks. Break it down into chunks. Just like those of us that are front-end engineers that we always say, oh, when you come to designing front-end system, always go with the component-based design system. Like I always do. If any of my files, any front-end file that you've written is going more than 300, 400 lines of code, no, it's not scalable anymore. Break it down into components, right? You understand that. But I can tell you that here I can actually go ahead and write 2,000 lines of code for you in just one single file. It's because a problem for maintenance, right? The second is read it before you run it. Read the code before you run it. Check if there's a new package installed. Check the packages that were installed. Check if there's any package JSON file that seems like a script is being injected. These are some of the ways that systems are actually being getting hacked these days. Without you knowing, AI just go ahead, pull up a new package, and the package has actually silently inject a script to your package.json. Once you deploy that script, it starts firing you down, right? And the last one is the checkpoint, very important. Commit after every verified group so that if a problem happens tomorrow, you know the commit to roll back. Don't wait till everything is built. If it's finished with the task 1 and you review it and you see that, oh, this is actually a very good one, commit it to GitHub immediately. Don't wait and you go ahead and promise with task 2, promise with task 3. Then you now have like 50 tasks. You now commit it at once. If anything happens, it's because a problem for you to be able to track it, to trace it down. If you review the PR, you've run it and everything is okay before you commit it. That's the checkpoint for you. These are just an example where there was the code was actually going through to n+1, and I just have to convert it to a 1 DB round trip using the map method. But if I actually write something like this for you now, you don't know that under the hood, it is actually killing your DB, right? It's actually killing your DB using the reducing method because that is an n+1 algorithm already. Why don't you just use the map, save it in memory, and just one single wrap, you have whatever totals or information or users that you want to get. These are one of the edge case scenarios that AI might actually run you through, right? If you don't review it. If AI generated this for me for the first draft, and I did what I say, no, this is an n+1, then you can actually review it. Make sure that there's human interference in every AI code that is being written. And last principle here is for you to flip the script. Let AI be the reviewer and not just the author. AI is always very good with reviewing PRs if you know how to actually do it very well. Once you know, once you fix a bug or you implemented a new feature, let AI go ahead and review that PR. You will be surprised that there are some edge cases that you are not even actually looking at initially. That is going to catch for you. That is the beautiful and the creating aspect out of this, right? The PR self-review. You review the PR yourself, right? Then it's telling back to explain back your checks. You explain back your check. That means place your changes and ask the AI to explain what it does. If the explanation surprises you, the code doesn't say what you think it says. Sometimes it will hallucinate that it will think it's fixing the problem you have at hand, whereas your AI model is actually doing different things entirely. But if you don't self-review it, you might not be able to catch it. So if you self-review it and you see that this expectation is not what I'm expecting, you copy it and paste it for AI. You will see the explanation is going to give you. If the explanation is not what you are expecting, just know that you are actually doing an absolute not what you expect in that particular PR. And the last one is after you've done that and you've actually fixed it, then automate the PR so that it runs some checks, runs its tests, and see that everything is fine before it's actually put to production. And the last one is writing tests. Like I said, let AI write the text. I actually have some prompts now that I always use. I have them there. If I need to do tests, I have the detailed prompt of how I'm going to engineer the prompt to actually get what I needed. Let AI be the one to write the test. So what are the guidelines? Like we said earlier, what are the guidelines that you need to take off? The guidelines are there's an human review for design and intent, right? Put that, always have that guideline. The second is the AI code reviews both on every PR. Have an AI code review both. You can use, there's one, is it Clio AI now? You can use that. You can use even Cursor, right? Most of the time, I always have my prompts. When I'm done in design presentation, I copy my prompts, open a new Cursor terminal, paste it, and tell him, review this particular comment, compare it to what we have, any changes, any edge cases to be cached, any bug that was not cached, anything that can be improved on. It does that seamlessly. So always have that in mind. Always have your CI test and coverage threshold. What are the testing that you want to check for? Ensure that you are the one doing your security and deep scanning. In case of any secret detention, license packages that is not valid or packages that AI has actually brought into your code that is having issues or that have been injected with scripts. You have to be able to catch them. And lastly, types, links, and format. You should ensure that your codes are formally typed, linted, and formatted, right? And what are the 6 habits that turn AI speed into the AI debt? What are the 6 that if you do it, you will think you are actually speeding to production or speeding to market, where you are intentionally creating technical debt for you to come back and fix. Like I said, technical debt is an interest. Either you like it or not, you will pay for it. That's the truth. Technical debt is an interest. Just like you went to bank and you borrow loan. They borrow you 50K. And they tell you that the interest every month is 10K. The longer it takes you to actually do the right thing with your code, the more interest you're going to pay for it. There was a very popular meme that was going online where someone created a calculator, and the calculator, you have to click on it to even subscribe on the calculator. There was also another one that was saying someone was trying to log in, and he vibrated the code, and the code was saying, oh, password already exists. This password exists for www.xyz@gmail.com. That security breach already. Your vibrated project have revealed the password of another user on your platform down to an unknown user. Now imagine that project is for a fintech now. That means I can just go ahead, log into that person, you can now wipe his entire account, right? So the first one is, if you are merging without reading the code, is a technical debt that you will pay for. AI likes the code, you just merge it and you don't read it, it's a technical debt. If you are prompting and you are praying debug, prompt and pray debug. This is how prompt and pray debug works. They gave you a bug to go and fix. You fix the bug, and it looks good. You don't even review it. I pray this is going to work. When you say I pray this is going to work, and you just push the code to production, that means you prompt and pray because you're not even sure what exactly it has done. And this always happens most times when we are not even the one that wrote the code in the first instance. The third one is vibe coding to production. When everything about that project is vibe coded, it's always look at an abandoned building. Everything looks fine on the outside, but you see the inside then that they've not painted, they've not done anything. That's how it looks like. It will look glitchy on the outside, but the inside is crying, right? The fourth one is outsourcing your architecture. Like I said, your design architectural system should be done by you, not by AI. Secret and IP in plot. You copy your Stripe IP, you give it to Claude Code to help you to debug. Bam. You copy your key down to paste to Claude Code to debug. You copy your Firebase key down to Claude Code. You copy, secret keys that should, and God that will not catch you. You are not even having some security implementation on those keys, on those platforms. Maybe your Stripe API key. You don't add IP restriction to it to ensure that it's only your server that can actually make a call with that IP address. Then it becomes a problem. Because there are also bots and AI too that are actively scanning the prompt and conversation that people are having with all these Claude codes. And once they see the key, it gets to the hand of the bad hackers out there, and they make use of it. So just that your company is losing money without even knowing what is going on under it. And the last one is trusting embedded packages. Package injection is one of the most common issues right now. Hackers are injecting popular packages used by millions of developers. So if you trust that you install any package and you're not sure what is going on, it might actually be a problem for you in the future. So what is the team playbook? How can you be better? How can you scale at it? The first thing is write it down. Write it down. A one-page AI guideline. I have AI guideline that I use almost on a daily basis. Prompts that I've used over time that I know that they're actually working well for me. I have them down. So just copy them, paste them, make some changes based on what I want to do, and let it go. Then share the commit file. Most of those Claude agents always have something like a Claude.mt, and Gravity have its own Gravity.mt. Commit those codes so that by the next time you want to prompt the AI to do something, he is able to understand what you've been doing over time. But most of the time when I'm using Claude for my project, I make sure that I tell it to always update the Claude MD. So that tomorrow, even though it's not you, if another engineer coming up to work on that project, and he's trying to use Claude or whatever other AI agent, he understood what has been going on over time. And you'll be able to think in the direction of the project architecture so far and not inventing a new one. The third one, build a prompt library. I have my own prompt library. If you know prompt that you know, this prompt works best for you when you do it. Not just say, write, validate email, implement login. No, those are not prompts. Structured prompts that have the context, the constraints, the acceptance, the review, and everything. If you have those ones, build those prompts. Those are your prompts library that you can actually scale up with. Pair on AI workflows. Then same bar for all code. Don't say because my implementation this place was very small, let me just put to production straight. No. Make sure that your flow is the same for all. Then review the reviewer. Review the reviewer. The reviewer is AI. You are the one to review it. Review what AI has reviewed to make it better. Review what AI has reviewed. In that way, based on your own experience as a senior person, you're able to catch some things that it might have actually overlooked. And the measurement, measure outcomes, not the output. Measure the outcome of what it's doing, not the output. Don't count the line of code that are generated. Count the lead time for those changes. Don't count that, oh, this my AI code was able to generate 5,000 lines of code. No. Count the outcome of what the code generated has actually been. I think I generated more code and it leads to more bug for you to fix. Count them. The AI suggestion acceptance, but your major outcome should be the change failure rate. Was there any feature that was being pushed that caused issue in other features? Those are what you should be looking at. Then the code churn within the 14 days. Was there any technical debt that the AI itself even created for you that you don't know? Then count the time to restore service. If there's any service or any commit that the AI did for you, you push and it leads to problem, and it took you time to restore. Those are what you should be counting that, is this AI really profitable for me, or am I using it the right way, or it's time for me to actually scale up in my usage of AI? Thank you so much. I think that was the end of my presentation.
Wow, wow. Thank you so much, Ebenezer. This was really, really insightful. I mean, I don't know about you, but I personally have learned a lot. Wow. Okay. So I think we can go into questions. I don't know if anyone has questions. Okay, so we have a few questions here. Please, if you have questions, feel free to drop them in the comments and all your questions will be answered. So the first question here is, most of the time when I try using AI to code, yes, it does the work fast and simple, but it takes me more time to fix the bugs. Why? So I'm not sure who to ask this question between Rex and Ebenezer. Maybe you guys can pick who answer. Okay, I think we should throw this one to Ebenezer.
Yes, like I said, it takes you time to fix it because you did not prompt it right. I think when you prompt it right, it won't be a problem for you to fix. Like I said, the quality of whatever code AI is going to generate from you depends on the quality of prompts you've actually given to the AI. If you are more focused on getting the work done faster, then just be ready to actually face the consequence of the technical debt may actually create for you, which are those bugs, right? But if you are trying to implement something or you're trying to fix a bug and you give him full context, in fact, sometimes especially when it comes to bugs, I go to the page that it is. This is the page. I screenshot it, draw an arrow, copy the image and paste it for the AI, even before you now start giving him more prompts. Copy the URL, if it's a front-end project, copy the URL in your local host where the bug is, copy it and paste it for it as well to be able to understand it. And at the same time, to now go back to your prompt and prompt it correctly. On this page, users were clicking this, but this was the experience they were having. I want you to fix it in this way, where once user click on this button, an API call should be made to this endpoint and return with the success or failure response. Clear context. So that way you not just go ahead and start hallucinating, where did CCU happen? But instead of that, I just go ahead and say, when you start click on sign up button, they got an error. Fix this. I can tell you that if you go ahead and start doing a lot of things that you don't even send it in the first instance. So most of the times when we prompt it wrongly, we get wrong results. So it's taking you more time to fix it because you did not take the time to prompt it right in the first instance. I think that would be my answer to that question.
All right, thank you so much. Kiddy_football. I hope that answers your question. So we'll move to the next question. This is from Igbo Ted. It says, how can we use AI to improve processes, like you said, architecture, workflows, and reviews without sacrificing quality and learning on the job?
Okay. Like I said, the learning on the jobs comes into place when you are reviewing the PR. Because if you leave it to AI, you never learn. You never learn what you don't read, right? So how do you now improve the process is the first thing that I talk about, you will see from that flow slide that I drew, was the planning phase. You plan that phase together with the AI. This is what I'm trying to do. You have the conversation with it. Oh, I'm trying to build something like Jumia, where multiple users. Then you tell him the difference of, oh, Jumia has this, but I want to implement Jumia and more. Those new features, those are the planning phase. From that planning phase, it's yet to write any code at all. Then it comes back with, okay, based on your context you've given me so far, I think this, we'll go through this way, go through this way. Then you review the plan. If you feel that is not something that will work for you, you prompt it back. Instead of this, why can't you throw it to this place? One thing is, if your thinking process is not something that will be scalable for the system, sometimes AI are always smart enough to let you know that this will not be scalable, right? Then after the planning phase is where you now come in. The design, architectural design system should be on you. You know the stack you are comfortable with working on. You know what you want to do. You know what should be your database. You know what should be your framework. You know what should be, maybe you want to use an event-driven system, or it's going to be a microservice architecture. Maybe you want to do Redis and Bool. You know, maybe there's going to be web bools. Maybe it's going to be WebSocket. You know all of those. Those are the architectural decisions. You feed it with that, right? So in that process, by the time it's coming back with the kind of code it's going to come back with, he knows what you want. If it's the backend, you tell him that, okay, there will be entity, don't make use of the entity anywhere. There should be structured repository for each of those modules. Your user module should have its own repository. There should be an abstract repository that will be global to all of your repository. You give it your own engineering principle that you want it to actually think like you. So in that way, by the time it's coming back, it will never sacrifice the quality of your code. And the kind of code it's going to return for you will be the one that will follow your own coding pattern and coding system, and not just a vibe coded all at once code. So in that way, by the time you come back, you review it. One thing is, if you are reviewing it, you will learn in the process, because there are a lot of clean architecture that it might actually even do for you that you might not be exposed to initially. But because you're giving me the architecture of what it should follow, it will even refine it and even do it way more better. The problem is, if you don't have a structured architecture that you always follow your engineering principle, that is where the problem will now come into place, because you don't even know what you're going to tell him to actually follow, or how he's going to do that. I hope that answers your question.
Ted, I hope that answers your question. Okay, thank you so much. So I have a question here. I think I wrote it down. So what I wrote here, actually, you mentioned something about AI being the junior engineer. Okay, Ted says you answered this question. So you mentioned something about AI being a junior engineer. So what qualities distinguishes developers who become more valuable with AI from developers who become overly dependent on it? Did you get that question?
No, can you come again?
Okay, so if AI is essentially acting as a junior engineer, which you already stated, what qualities distinguishes developers who become more valuable with AI from developers who just become overly dependent on AI?
That is architecture. That's the single value, the architecture of the system. If you are overly dependent on AI, your code quality will not be properly architected. And if you get to a point where you cannot even maintain what AI has written for you, unless AI itself go back and fix the problem. So if you are getting to a point where your own code base is now being owned and signed exclusively by AI, you don't even know what is going on under the hood, then that is where over-dependence comes into place. So the distinguishing factor will be the architecture you are putting into place to ensure that AI is thinking like you. Not only thinking like you, but at the same time too, providing solution to bugs and issues the same way you will do it. So that way, when you are reviewing it, you are not just reviewing like, what has this thing done here again? You are reviewing with clearer understanding and concept of what is going
Thank you so much. I think that answers the question. I don't know if you can hear me. Can you hear me?
Yes, loud and clear.
Okay, thank you so much. I don't know if any other person has any other questions to ask. Um, okay, so I think this one is for Victor X. If you could establish just one AI usage rule that every software team in the world had to follow, what would it be?
Sorry, can you ask the question again?
Okay, if you could establish just one AI usage rule that every software team in the world had to follow, what would it be?
Okay, so I would say clarity is everything. The more clarity you have, and the more clarity your AI has, your agents has, the better the output, basically. Um, In fact, actually, that is even a standard rule as it stands with this AI coding products. You can see that as they release new versions, they try to improve the amount of clarity it gains by asking you questions. You might want an implementation and it can ask you questions to gain more clarity. So, clarity is everything. Ensure that in whatever you're doing, there is no abstraction. There is, let's say now, for example, now there's an abstract, what could be considered an abstraction is, okay, you know that the AI implemented Google authentication, but you do not know the flow the AI actually used to implement that Google authentication. You want to ensure there is clarity at every level. So clarity is everything. That is the rule I would say. Yeah.
All right, thank you so much. So I have one more question for you. Yeah, I will take you back to the part about architectural diagrams and the part where you mentioned the whole diagrams, AI assisted development. So for developers who don't naturally think visually, how important are diagrams in AI assisted development?
Okay, so I would say they have been important as, or they are as important as it has been, from the beginning of software development, if not even more important now. So, in a standard software team, before implementation actually begins for a particular feature or product, there is always the planning stage. The planning stage is where you see research, diagrams, flow, all those stuff. So it is very important because just the same way when you want to build a house, you need a blueprint. When you want to build a product, you need a blueprint. Those diagrams are basically the blueprints. They're the blueprints that help you see, okay, there could be something we're missing or this could be a point of failure. So without those diagrams, there's no visualization. And without visualization, there's no complete clarity.
Okay, well, thank you so much. I think that answers the question. So this one is for both of you now. Before we wrap it up, because I can see that no one else has any other questions. In fact, today's session has been, I still need to go back to, digest everything that we've learned so far. But this one is for both of you. 10 years from now, what do you think will separate elite engineers from average engineers when it comes to coding ability, architectural thinking, or even the ability to collaborate effectively with AI?
Hmm.
I don't know who wants to
So
go first, but both of you.
okay, I'll just go first since my mic is still unmuted. So I would say what separates engineers in the next 10 years is it lies towards architectural thinking, but not just architectural thinking, more about system thinking. System thinking is a superset of architectural thinking. What I mean is that you find architectural thinking in systems thinking. Systems thinking is basically it goes beyond just thinking about data flow, edge cases, schema designs, and all of those stuff. System thinking goes into understanding how the software works, how your programming language works, how a computer works, how things happen in the network. So the more knowledge you have about your field, the better you are as an engineer. There could be problems that could happen that are compiler errors. Even if you're good with architecture thinking, if you do not understand how basically the computer field works, basically how, let me say, compilers work, for example, garbage collection and all this stuff, you might not be able to detect it. It could be a security vulnerability that is operating at the low level stage, probably reading sensitive data from the memory. The better you are at understanding these advanced concepts, the better you are at engineering in general. So yeah, that's my answer.
Thank you so much, Victor. So Ebenezer, let's hear from you. Do you need me to take the question again?
Yeah, for me, I would say three things, right? The first one is your technical know-how. What do you know? It's not even a matter of I'm a software engineer now. Your technical know-how, one. Two is your experience, because a lot of things actually come with experience. And your prompt engineering skills. I always tell people prompt engineering itself is a skills. And it's not needed, not just for only developers alone. Even for non-developers, you need to know how to prompt engineer very well. And the world is moving very fast. If we get to a point, probably, I will not be surprised, maybe in the next 10, 15 years, when they say software engineer needed, no AI tools. I will not be surprised because we're actually going there right now. Amazon have finally told their engineers, like 20,000 engineers, that hey, we don't have the money to start burning because their whole entire AI credit that the company actually, budget for the entire year, God runs out within 4 months. So we are moving to a point where we will start seeing the real cost of using AI. We are not there before. Copilots were previously charging developers per month. But now they said, there's no more per month. They're not charging per tokens. Right? So by the time we start experiencing and seeing the real cost of AI, it will be done and everybody will get reformatted to factory settings. What I mean by factory settings is it will now be more of what do you know, what experience do you have, and how can you really prompt engineer the AI so that it doesn't consume a lot of tokens. One of the ways you can actually burn your token faster is a poorly prompted session with any of these coding partners. It burns your token fast. But if you have a good prompt, a good instruction of what you want to do, instead of burning like 5,000 tokens to solve a problem, you can actually not burn more than 1,000 or 2,000 tokens. So the better your prompts, the lower your cost. And it's going to pay not only you, but whatever company you are working for as well. Because as time goes on, when companies start seeing the real cost of AI now, which is where we are actually going to now, the reality is the cost of these our AI models before were actually being subsidized. Just like the Nigerian government, when they are subsidizing petrol for us, and everybody's enjoying it. But when the real reality of what petrol cost is coming up now, people no longer run generator from 7 p.m. to 9 a.m. in the early morning again. You start seeing them saying, hey, talk about going off that no, we have to solve it for 2 hours because we are using the same fuel tomorrow. That is where the AI world is actually going to at the end of the day. When we start seeing the real cost, what will now separate a senior engineer or an established engineer from a junior engineer will be their experience, will be their thinking process. People will not be interested in more on how do you think towards solving problems and how effective they can actually prompt engineer. I think that's the 3 things. Thank you.
Wow. Thank you so much. Today's session has been an amazing one yet, and really grateful for both of you for taking your time to break down every single thing for us. So I just put down a few points here before we wrap up, because I think we've gone beyond time. So we have here that AI is a tool. It is not a defining factor of quality. Speed without discipline is just faster technical depth. If you can't review it, you can't maintain what you don't know. And don't let AI run more than one task at a time. This is just a few points among so many other points that we're giving today. And we're really grateful for everything that you have taught us today. Thank you so much, Victor. Thank you so much, Ebenezer, for today's session. It was an amazing one. Thank you so much. And I hope every other person that joined this live session enjoyed today's session. It was amazing. So I think that's a wrap for today. Thank you so much. Please, if you have any more questions, you can always still ask these questions on our social media handles. If there's something that you wrote down but you couldn't ask it here, feel free to ask the questions on our YouTube, LinkedIn, Instagram. We're always available to answer these questions. Obviously, we'll send them to them and then they'll give you the response. Once again, thank you for joining today's live session. Thank you, Ebenezer. Thank you, Victor. And we'll call it a day here. Bye.
All right. Thank you, Princess. Have a good day. Bye. Bye, Rex. All right, guys.
Since we're familiar with the outsourcing community, it's the fastest that we have experienced. I recall that we had reached out barely, I think it was even over the weekend, right? And that was even interesting because you reach out weekend, you will not expect responses until, the beginning of the week. But we got a response over the weekend, and by Monday, we had already been given, I think it was a link or something that said, okay, we should fill our request. And as we filled that request link, under 24 hours, we'd received the feedback that, they had selected and lined up candidates, right? And so our HR team lead reached out to me and just said, we've already gotten candidates. I said, from where? They said, from ProDevs. I said, okay. So how many people are we expecting? And I said, they've shortlisted 4 people. And I'm wondering, between Saturday and we're talking about Tuesday, how did 4 people get shortlisted? It could have been one or two things. Either we're extremely very lucky, or the process is so efficient and has a very wide talent pipeline where they just, go in and fish, which I think was actually the case. And interestingly, by Tuesday, after we confirmed, it was now prejudiced on us, right? And so we got a follow-up, I think it was either a text or an email saying, okay, so you need to confirm when you want to see this talent. And so we had to even wait an extra week because of all the things we had planned for that week. And by the following week, again, it was prejudiced on us. This talent came in and, we started the interview process. We finished and concluded. Then we knew who we wanted to work with. And the most interesting bit was, it wasn't about even selecting the person we wanted to work with. We found out that the other party, there was another candidate who was suitable for us to actually work with, as on a project basis. So kind of like we got 2 for 1. You see what I mean? So that was very, very interesting for us.